Okay, so another term that we need to learn is experimental error. So this is the variation in the observed values of the response variable from the experimental units treated alike. So if you can imagine, there is this treatment level or condition or procedure applied to an experimental unit. Okay, but take note, you do not only apply once, okay, the treatment level to only one experimental unit. You have to consider more experimental units, okay? And then you also expect that these experimental units must be have the same responses or outcomes, or at least they are close to each other, right? Okay, so now if they are different, or there is this discrepancies or differences among these experiment or responses from these experimental units, then that's incorporated in the experimental error. Okay, so we need to have a measure of experimental error. That's why we need to come up with many experimental units or replicates. Okay. Why? Even if we try to control, and even if we try to only apply one kind of treatment level in several experimental units, okay, they still differ because of some reasons. Number one, inherent variability of the experimental materials, maybe because of the material used, no. Errors in experimentation. So it is usually the human error. Okay, it's the person who is measuring or gathering the data. Then errors in observations or in the measurements. Okay, so these are some sources of discrepancies, no. Then we also have this combined effects of all extraneous factors. So there are other factors that we need to know, or at least we need to have a good background of that certain kind of research. At least alam natin kung ibang factors that can contribute to that response. Okay, so we need to also try to control them. Okay, because they actually, yun nga, the source of experimental error. Okay, so just to illustrate, okay, so I think you're already familiar with this picture or diagram. Okay, so the experimental comes here. Okay, so this value is here. The discrepancies between Y11, the Y12, and the Y13. Okay, so the discrepancies again are incorporated in the experimental error. Now, another example. Okay, so under experimental errors, I'll just show you. An experiment was conducted. It's the same example, the potato example that I gave you. Okay, the experimental error there consists of the pooled variation, okay, the pooled discrepancies now, among the 5 plots. So what are these 5 plots? Yun yung experimental units natin. In the same sulfur application. So in the same level of sulfur, say 300 or 600 or 1,200. So at least now, no, we learned that we have this experimental error defined in this way. So it's the pooled variation. Okay, another term that we need to learn is sampling error. So if we have experimental unit, we have this experimental error. Then if we recall, we have the sampling unit, so we also have the sampling error. Okay, so sampling error is a measure of variation among sampling units within an experimental unit. So if you can imagine, yun nga, we conduct subsampling, or we use subsamples, okay, when sometimes we cannot measure the whole plot or the whole experimental unit. So sometimes we get 3 or more. Okay, so those variation of the responses of the sampling units, okay, are incorporated naman in the sampling error. Okay, so that's it. So we have experimental error, we also have sampling error. Now, we have an example here, just to give you an idea. Okay, so recall we have this hot dog example. We have 3 types of hot dogs, and then we get 3 packages from each flavor. And then from each package, we get how many? 3 hot dogs. Okay, so now the variation of these 3 hot dogs, the differences in terms of calories, okay, are incorporated now in the sampling error. So sampling error consists of the pooled variation among the 3 hot dogs taken from the same package. Okay, that's it.